This is a technical demo of systems, roles, and capabilities. So just some initial definitions. A system is a subset of a model's physical build. And that subset can be rearranged following a functional theme, for example, electrical or hydraulic or radio. So it's a different way of looking at a subset of a model. And that subset or system can be independently statused by the BDI. And roles and capabilities are related. A role is simply a top level capability. So we talk about an aircraft having a particular role or being able to fulfill a particular role because of its capabilities. So we denote a top level capability as a role. So moving on from that, then a capability is a combination of several things. First of all, it could be one or more model configurations and or system configurations in some combination that we'll see later. It can also include mod states, which would be one or more technical record compliance of those technical records. It can also be component specifications. So in Maximo, for specific part numbers, you can set up specific specifications, and we say that those are required in some cases for this capability statement to be met. And then finally, other capabilities. So one capability can require that the aircraft has these other capabilities. So there's an interdependency. The demo is very dependent on the data that we're using. So I'm going to be showing data in various different formats to help visualize what's really going on here. This is just a Word document that outlines the various configurations in use. So I've created this model called a GS1040, which is a completely fictitious aircraft model. And obviously there's a base variation at the top. And then I've created this 1040E variant, which is non-abstract, and broken that down into three separate sub-variations, V1, V2, and V3. And I've also created this night surveillance configuration, which is the -NS. So that's my set of variants. Then you can see I've defined two different systems. There's an ISR system, which stands for Intelligence, Surveillance, and Reconnaissance, which is the acronym that I'm used to. And then also an engine control system. And obviously we'll see how these two systems fit into the overall picture a little bit later. And then I've defined a top level role. So now a brief discussion of the model's build itself. And this is shown in an Excel importable format. So you can see here it's quite a small structure. There's only 28 positions. And some of them I've colored in orange because they make up the ISR system, which we'll see in a minute. So finally we'll look at how the role itself is defined and the associated capabilities that make up that role. Now this is quite complicated, and understanding this is key to understanding this new feature that we're going to offer in Maximo. So I'm going to go through this step by step. This is absolutely critical to understanding what the demo's actually showing. Now there are 9 records here, and we'll go through them one at a time. The top one's easy. It's of type role, and this is like, if you like, a header record that says this is the role definition. And in this case, there are 3 sub capability records associated with this role of 3 different types. And how these are rolled up is dependent on this CSL statement. And this is a Boolean expression that tells the BDI how to combine the results of these three subchecks to decide if this role is fulfilled by whatever aircraft it's evaluating. So we'll go through these one at a time. The first one is of type capability. And what that means is that this is an interdependency between this capability, line 4, and another capability which is defined by this value right here. And you can see this has a different prefix. This one's NS-nightviz and this one's NV-nightviz. And this one's separately defined down here. So we'll come back to that in a moment. So essentially it will evaluate whether or not that capability is met or not. Then it will decide whether or not the aircraft in question meets this configuration, and it's defined by this reference. So if we looked up that aircraft model, the GS 1040, that's the name given to the night surveillance configuration, the -NS, which we saw earlier. And then third, it will evaluate whether or not this technical record's been embodied for that aircraft. So it'll come up with 3 Boolean results, 1, 2, 3, which each will be true or false. Evaluate this Boolean statement, and that will determine whether or not the aircraft in question meets this rule. That's essentially what the BDI is doing. Now we skipped over this one because this is a dependency on another capability which is defined down here. So to evaluate whether or not this capability is met, there's another expression at the next level down. And this has 4 sub capabilities of different types. And you can see this is a much more complex expression. There's 1 and 2, or 3 and 4. And this expression could be even more complicated than that. There's no limit to how complex this could be, using brackets and ands and ors and essentially Boolean logic that gets evaluated. But in this case, it's going to evaluate these 4 sub capabilities to determine whether or not this one's met, which of course will get rolled up to the next level and rolled up to the rule. So the first sub one is a configuration type, and it references the ISR system, which again, if you look back at the configuration list, we defined a system called the ISR system. So it's going to check that that system and its components are in a valid configuration. Then it will check this specification, and this references a particular label and position and a specification associated with that part number. Thirdly, there's another configuration check. This time it's the other system that we defined, the engine controller, and then another specification. And it will combine the results of those 4 checks using this Boolean statement, come up with a result which gets rolled up to this level, which gets combined with these to make up the rule. So you can imagine how complex this could get. I've only defined a few capabilities here, but there could be dozens or even hundreds of such capability statements to define whether or not a rule is valid or not. So it's a very comprehensive solution. This may look complicated, but essentially it really isn't when you get used to it, but it's completely new to what we've been looking at in Maximo for aviation before. So that's how the rule is defined. So now we'll have a quick look at our data in Maximo. So I'm going to go straight to the Models app. And there's my GS 1040. So I want to have a look at the configurations. Now you'll see 3 headers. There's variant, systems, and rules. So we'll have a quick look at this. There's the base variation. Here's my abstract eagle. And beneath that, there should be 3 non-abstract variants, V1, V2, and V3. And at the very bottom is my surveillance configuration. So that all looks good. And I should have 2 systems. There's my ISR system and my engine controller, and then there should be 1 rule, the night surveillance rule. So that all looks good. On the build hierarchy, and this will show by default the physical build, as usual. But now there's this new perspective field. So if I want to look at my model from the perspective of the engine controller, I can change this perspective. So I'll pick this. And if you remember, I had set up 4 positions that make up the engine controller system. Here's the top level, and then here's the 3 subpositions. And that's a view of the engine control system. Okay, to save a little bit of time, I've skipped a few steps. But what I did was, in the Models app, I went in and made the power supply unit mandatory for the ISR system configuration. And then I created an aircraft in the V3 configuration. And then I went into the aircraft in the aircraft app, and I removed the power supply unit. Now I'm going to connect to V8 directly and start asking the BDI to show me some of the results. So let me just connect here. And this is not something that a customer would normally do, connecting via VEX, but there's nothing wrong with it. So there's there's the current configuration, the V3 configuration. And you can immediately see that the power supply unit is missing, and we're getting an SMO code, which is a warning. And the SMO stands for a missing optional position on the structure. And you can see down here that we've got 1 warning. And that's exactly what you'd expect, because the power supply unit is only mandatory for the ISR configuration. So the next thing I'm going to do is ask the BDI to show me the ISR system in the ISR system perspective. And there it is, and the power supply unit is missing. And the VS command doesn't actually validate the system. It just shows me that perspective. But the very next thing I'm going to do is ask it to validate that system. And there we go. So it's now showing me the whole aircraft from the perspective of the ISR system, and I am getting an SMM code, which is an error code, and it's a missing mandatory position. Again, that's what I'd expect. So to recap a little bit here, the aircraft itself is in a valid configuration. As I just showed, it has an SMO warning, but that's fine. But the ISR system is in an invalid state because the power supply unit's missing. And if we go back to our rule, and part of the definition of that rule, there's this Boolean clause, which in a nutshell says that the night vision capability depends upon either the ISR system or the engine controller being in a valid state, one or the other, or both. So the very next thing I'm going to do is ask the BDI to validate the night surveillance rule and see what it says. And this time we're back to getting an SMO code. Now we're getting the SMO warning, which is not an error, despite the fact that the ISR system is missing its power supply unit. So all I'm showing here, or trying to prove, is that V8 has correctly identified that despite the fact that the ISR system is in an invalid state, it's still saying that the night surveillance configuration is valid because of the OR clause, because of this OR right here. It goes on to see if the engine controller is in a valid state, and it is, and that's why this configuration is okay and valid. This aircraft meets the night surveillance rule specification. So that's a very technical demo. The next stage in development, I guess, is to make all this work via the Maximo front end. And there's a few minor problems, but we can see at this point that V8 6.3 is actually validating all this data, and we're getting the results that we expect. So I hope that was helpful.